last week we started to see some things we can do just with one line of code. We saw some list comprehensions and other syntax. So today I want to continue with this line and see how we can do more things just in one line. So let's see how we can turn an if-else statement and compress it to one line. So here we have an example where you see the classic syntax of if-else. So we iterate through a bunch of numbers. If they are divided by 2, we print that they are even. If not, we print that they are odd. And it turns out we can take this if-else syntax and compress it to just one expression of one line, like you see here. So you can see that this code does exactly the same. Now, the way this works is we have this one line if-else expression, and you can read it as even if I is divided by 2, else odd. Now, the way to interpret this kind of syntax is you first go to the if statement, you get some Boolean. If this Boolean expression turns out to be true, you will get the left side to be evaluated. And if it's false, you will get the right side after the else to be evaluated instead. So this will give you some expression that is even if this condition is met. And if not, it will be odd. And then you can take this expression and do whatever you want with it. You can put it into a variable and then use it to print something. And if you really want to do that, you can even compress this thing even further and make everything just in one line. You can even create a for loop that is one line, basically by just getting rid of the line break and putting the expression of the iterations right after the colon. And here you can see we use this if-else statement inside, and we don't even assign it to a variable. We right away put it inside a string using this modulo formatting string syntax. And again, you can see that it does the same thing. Now, I will say that it's not really recommended to do that. It's really cool that we can do all those things in just one line, but I think it's not a very readable way to do that. And in general, I would not recommend you to use for loops, I mean regular for loops, not the list comprehensions and stuff like that. For the regular for loop, I recommend you to always begin in a new line. It will be more readable, and there is hardly never a reason to do that. Okay, here is another example. So we've already seen in this course like a million different ways to turn a DNA sequence into an RNA sequence. So here you have it, the 1,000,001st way to do that. You can use this if-else syntax to check for each nucleotide whether it's a T. And by evaluating it within the list comprehension, you will get a list of RNA nucleotides, which you can then join and get the RNA seq. And there are even more things you can do just in one line. Sometimes you can see people use the semicolon to make, it basically just breaks down the statements and run them one after the other. So it is completely equivalent to just running them in different lines. Again, I think it's bad practice and you should avoid it. There is really no reason to do that. It's more readable if every statement has its own line. Maybe one reason that sometimes you may want to do that is, for example, if you use the Python command line, but you don't really want to open a new Python interpreter, you just want to evaluate something and exit. There is the syntax that you can use. I think it works mostly in Linux, but maybe sometimes it works in Windows. Let's try. OK, yeah, it works. OK, so this is a command line syntax that allows you to run Python and just run basically with just one line of code and then exit. Sometimes you use that. So for example, if you're running on a computer and you want to see what version of Python you run with, you can create some different statements within the same line. You can import the sys module and then ask what the version is and print it. And it all happens just in one line of code. Other than that sort of a thing, really, there is no reason to use that. So please don't. And here's another example that this whole concept of one-liners can be somewhat abused. Can you guess what this code does? It gives you all the prime numbers between 1 to 100 using a very ugly and unreadable and very inefficient one-line algorithm. So again, just because you can do things in one line doesn't mean you should. So most of the time it's all right to do things in many lines of code. Do use one-liners only if you think it makes your code easier to write and to read, and if it seems like the right thing to do. But you need to use some common sense. Okay, so that's about all I had to say about one-liners. A final topic I wanted to cover before we go to the lab exercise is what is known as the args and kwargs syntax. So again, let's begin with an example. We saw that there is this built-in max function which can either take some list or iterable of numbers and give you the maximum number, or it doesn't even need to have a list. You can just give it a bunch of different arguments, and it can handle them each one as a separate entity. So you can give it 2 arguments or 4 arguments, 5, 10, 100, as many as you want. Now you may wonder, how does it work? Because we've seen that when we define functions, we need to pre-specify the exact number of arguments that we are going to give it. But here you see a clear example of a function that can in fact handle any number of elements, of arguments. So if you want, you can do that too. And there is a syntax to do that. That's the args syntax. So the way it works is when you provide here a variable name to the function, you put this small asterisk before it. Now, what it means to Python that it is a function with an argument name that is preceded by an asterisk is that this doesn't necessarily have to be just one argument. This could be any number of arguments, and it can fit in whatever you give it. So for example, if we call f with 2 arguments, then this args variable, it will end up getting a tuple of 2 elements. If you give it 3 arguments, it will be a tuple of 3 elements. And if you give it a list of 3 elements, then it will be a tuple of just 1 element, which happens to be a list in this case. But it's just 1 argument. And you can even call it without any argument, and you will get an empty tuple with 0 elements. Okay, so this allows us to define a function that is rather flexible in the number of arguments that it is willing to receive. So let's see an example of how we can use it, and let's define our own implementation of the max function. So here I define a mymax function, which gets any number of arguments. Now, if I give it just 1 argument, then it assumes that this argument will be some kind of a list, maybe, and it will treat those as the values. Otherwise, the values will be just the different arguments. So it will assume that each argument is a different value. And then I create this logic which iterates through the values, and if I get a value that is bigger than the current maximum, I update the maximum and return the max value. And you can see that it works. It works if I give it just a list, it will give me the maximum value within this list. Or if I give it separate arguments, then it will just pick the maximum value within these arguments. Questions? No, so you see that if it's not the length of 1, then I assume that each one of the arguments is a different value. Okay, so if I didn't have this condition, it would assume that I have just 1 value, which in this case happens to be a list. And it would try to compare this list to something else, and I basically would get the list instead of the maximum value within the list, which is what I want. Okay, so if I didn't have it, if I just took the values to be the args, You see that now I got the entire list as the maximum value. That's not what I wanted. I wanted the values within the list to be iterated over. Any more questions? Okay, and now we can also combine the two approaches. So we can have some arguments which are fixed, and then we can basically collect all the other arguments into some other variable which will take them. So here we have two fixed arguments. We have a and b, and all the other arguments, we just pour them into this args variable, and we can do some logic with them. We calculate a times x plus b for each one of the x's in these other arguments. So if I call it, for example, with 2, 5, and then 10, 11, 12, I will get 2 times 10 plus 5, 2 times 11 plus 5, and 2 times 12 plus 5. Right, and now, like we saw with the keywords arguments, it's not a good idea to have those mixed in. So if you use a mixture of predefined arguments with these args, you should always make sure that the rest of the arguments will be at the end. Otherwise, again, it creates this ambiguity which Python doesn't really know how to handle.
Can it come in the beginning? So we can make args and then defaults, or is it?
No, you should probably use it at the end. Yeah. Okay. So we saw that we could have functions with any number of position arguments. Now it turns out it also works with keyword arguments. So for example, we have the format function of strings, which can get basically any number of keyword arguments, and then it uses them like a dictionary to place them, to make a formatting of the string that it gets. So we can replace who inside these curly brackets with nobody, and replace nation with Spanish, and we get nobody expects the Spanish Inquisition. Okay, so this is again a built-in feature of Python, and we can also do it ourselves. So if we also want to create a function that can get any number of keyword arguments, instead of this asterisk syntax, we can use twice asterisk. So we have the double asterisk followed by some name, which again, the convention is to use the kwargs as the name for these arguments. And what it basically does, it collects all the keyword arguments and turns them into a dictionary. So if we call f with white equals black, true equals false, and answer equals 42, we will simply get a dictionary mapping these keyword names to their values. And if we call f without anything, we'll get an empty dictionary. Okay, so this way it allows us to sometimes call functions with a somewhat different syntax. So we can see some example here that we can have a function that just gets a dictionary, and then we can call it with a dictionary. Or we can have a function that gets this kwarg syntax, and then we just call them with keywords arguments, and we basically get the same thing. And of course, like any dictionary or keywords, the ordering typically doesn't matter. So yeah, because it's just a dictionary in the end. And in fact, the constructor of dictionary also allows us to specify dictionaries in this way. So if we start a dictionary with 2 keyword arguments, it will just turn it into a dictionary, mapping A to 1 and B to 3. Okay, and like with the positional arguments, we can take the keyword arguments and combine them with fixed keyword arguments. So here we have one positional argument, A, and then we have a fixed keyword argument, B, and then we have all the rest of the keyword arguments. And you can see that if we call it f with 3, then it knows to assign it to the corresponding position argument, A. And then you give it two keyword arguments, which it puts within the kwargs because they do not match the b keyword. So the b just remains with its default value. It will keep the value of 0 in this case. And we'll have two additional keyword arguments, x and y, which will be given as a dictionary. And if we want, we can combine the two kinds of, we can combine args and kwargs together. And if you do that, basically when we call a function, basically all the position arguments will become a tuple inside args. And all the keyword arguments will be collected as a dictionary within kwargs. And you can see that we get a tuple with 3 elements and a dictionary with 2 entries. Now, sometimes we may want to use it in a reversed way. So we saw that we could define functions that receive a flexible number of arguments, and then we can call them. We can also have regular functions and invoke them with this reversed syntax that take maybe a list or a dictionaries and feeds them into the function as if they were separate arguments. So let's see an example. We have a function here that takes 3 positional arguments, a, b, and c. And now we want to feed it 3 arguments that we have as a list. So up until now, if we wanted to invoke this function, we would have to do something like f on abc at the 0th position, then on position 1, and then on position 2. And it would work, but it would be a less elegant way to do that. It turns out we can use the reverse of this syntax. We can just fit it in this list using the asterisk prefix. And then Python knows to treat this list as if it were 3 different arguments. And it just feeds it into the function as a, b, and c separately. And the same way it works with dictionary. So we can have a dictionary with 3 values. And then we can use the asterisk syntax to feed it to the function as if it were 3 different keyword arguments. Questions? OK, now if I really want, I can even combine them. So I can have a function that is defined using this args and kwargs syntax. And I can feed it a list and a dictionary using the reverse of that. So what will end up here is that, yeah, OK, so this will be quite strange. So we invoke f with 10, and then we take 4 additional positional arguments using this asterisk syntax. So this basically means we treat them as different arguments. It would be like removing this list and just giving them as separate arguments, but this is not what we do here. And then we use the asterisk syntax to provide 2 more keyword arguments. And what we'll end up getting is that a will take the value of 10, because this is the first position argument. Then b will take the value of 1, which is the second position argument. And then the 3 next values will go into args, and these 2 guys will go into kwargs. OK, this is a very twisted way to work with it, but I just wanted to show you that you could do that. So this is the kind of syntax that Python allows you to work. And as a final note, I wanted to show you some example of where this could become handy. And that's related to the zip function, which we saw in the previous lesson. So let's suppose we have 2 lists. We have x and y. X is a list of 3 elements, a, b, and c, and y is a list of 3 elements, 0, 1, and 2. Now, as you remember, if we zip x and y together, we'll get 3 tuples of the 3 matching pairs. So a and 0, b and 1, c and 2. Up until now, nothing new. Now, what happens if we want to unzip these pairings? We want to split them apart into 2 different lists. The question is, can we do that? And if so, what is the function that is the inverse of zip? Now, it turns out quite cleverly that zip is, in fact, the opposite, it's the inverse of itself. So if you want to inverse the operation of zip, you can just use zip. But there is a little twist. You will have to use this asterisk syntax. So this is a bit strange and non-intuitive, but let's try to figure out why it works. So if we want to unzip x and y, we can take the zipped xy and again feed it to the zip function, but we begin with this small asterisk. Now what this will do, it will make sure that this list with 3 pairs will be fed into zip as 3 different arguments. So we'll get a zip of a_0, b_1, and c_2. Now if you remember, if we take a zip with 3 arguments, what we are going to get is we are going to get triplets of the first element, then the second element, then the third element within each of the groups. But in this case, we have groups with just 2 elements. We have just pairs. So what we'll end up with, 2 return values with 2 things within the list that the zip gives us. The first one will be with the first items. The second one will be with the second items. And in our case, we know that the first items all come from x and the second items all come from y. So we'll basically get just a list of the 2 tuples with the original values of x and y. So you can see that we get ABC, like we had with x, and 0, 1, 2, like we had with y. The only difference is that we get tuples instead of lists. But if we want, we can even fix that. We can use the map function, which again we saw in the previous lesson. So we can map what we get into a list. Now what this will do, it will apply the list function on each one of the elements that the zip gives us. Now each one of the elements, like we saw, is a tuple with 3 elements. So when we apply a list on that, it will just convert the tuple into a list, and we will end up getting 2 lists with the original values. And you can see that when we compare it, we see that the first list is indeed equal to x, and the second is indeed equal to y. Okay, so this is just one example of where the syntax can become handy. There are other examples which we may encounter in the future. Final questions? Okay, so let's go to the lab exercise. Which I say it every week virtually, but this time really it's really an important exercise because like we're going to see, the homework exercise that we're going to have for this week is going to be a little bit challenging, and the lab exercise is really an important middle step to do that. And you can really see that many of the things that will be covered in the homework exercise will be first introduced in this lab exercise.